All right. Is the mic on? Yeah, I guess it's on. Thank you all for coming. First of all, I have to say I'm really sorry I'm not going to do this in French. I'm from Belgium, so I should be able to talk a bit of French, but you would be suffering through my French anyway, so I'll do this in English. And the title of my talk is Passwords Are So 1990s, and I don't mean like all the kids these days walk around in the same clothes I did when I was young, but I mean that it's a bit old school to use passwords, but we still use them. And in my opinion, there are some better ways because I hate passwords. Is there anybody in the room who does like to use a password or likes to remember all the passwords for all the different services? You're all lying, I guess. If not, go ahead, use passwords as much as you want. I'm going to be talking a bit about passwords and maybe what we can use instead of them. But let me quickly introduce myself. My name is Bellen. As I said, I'm from Belgium, and I'm a developer evangelist at Auth0. If you've never heard of Auth0, we're an identity as a service provider, which means that we try to make it as easy as possible for you to implement a secure authentication, so you can focus on building your actual products, your websites, mobile websites, whatever, mobile apps, whatever you want to build. I'm also a Google developer expert, and I organize a few meetups, one in Belgium, Frontiers, all about front-end, if you're ever in Belgium and happen to be at the same time as one of our meetups, to join us. And the Identity and Security meetup in London, which is a little bit further, but still not that far away. And if you want to find me on the internet, Sambego is my username on all of the available websites on all of the internet. The most important slide, I have cat stickers. So if you want to have a cat sticker, tweet me a picture of your cat or your dog or a bunny rabbit or your horse or whatever you want, and I'll give you some stickers after this talk. So let's get started. A little bit of a summary of what we're going to talk about today, a bit of history on passwords, an overview of all the different types of passwords that are available or commonly used these days, passwordless authentication, and last but not least, my favorite, something I'm very enthusiastic about, the Web Authentication API, which is a new API. It's a W3C standard since, I think, March. So we'll see a bit about that as well. A bit of history on passwords. The first written down fact or fact of passwords that I could find was somewhere before Christ. It was that the Romans used passwords to distinguish friend from foe. So if two groups of people would encounter each other and to know if they were friends or foe, they would use a password just to know if they should attack the others or just go get some beers together. A bit later, in the 10th century, 10th to 13th century, there was this book called 1001 Nights. It's about Alibaba and the 40 Thieves. Who's never heard of this book before? I think most of us know a bit about the story. There's these 40 thieves, and they hide all of their gold in a cave somewhere where they hid an entrance, and to open that entrance, you had to say, "Open Sesame." So this Open Sesame is also a password. But of course, we're at a web conference, and we also want to be a bit more tech-focused. So let's fast forward a bit to the 1960s. I think 1961, this guy, FERNANDO, invented the first password on a computer. He worked at MIT, and MIT had this huge time-sharing system. And a time-sharing system is basically a system that allows a lot of people to work on the same mainframe, the same hard drive at the same time. Because back in the day, they had 4 hours a day to work on that computer. But so that more people could use this one mainframe, he invented a password so they all could keep their own content safe and secure. Then, forward to the 70s, Robert Morris Sr. invented hashing, which means that the first 9 years of the computer passwords, all passwords were in plain text. It's not the best of ideas, but he worked at Bell Labs and he invented hashing, and it's most commonly used today to store passwords because we don't want to store them as plain text. Sometimes it still happens, but it should not happen at all. And then in the 90s, hacking became more of an issue just because the web started growing. We started to see more websites, more products started to go to the web because it's universally available. So people tried to misuse those products, tried to enter them illegally by hacking. So we have to get a bit more creative on how to store passwords, rainbow tables and stuff like this. So hacking became more an issue in the 90s. Bit of history, just so you know, it started with the Romans, ended up where we are now. A few types of passwords. What's a password first? Anything that's a shared secret, right? A password can be anything it's a secret that you know and the product you're using knows as well, so you can authenticate with that password. And the most commonly used one is a string. Don't ever use this password, please. I think that's obvious, right? This is my first password when I was young. I had a friend who had a password with hot dog, and I was like, that's genius because it's like a word that's not that common, but I want to make it a bit more crazy, so why not cold dog? Don't know why. I was very young. I don't use this anymore, so don't try to use my, my email address and this password on any of the services. It will not work. But a good password should look something like this, right? Something that's random with a lot of characters, some symbols, some letters, some numbers. It doesn't have to be, as long as it's long enough and you can remember it. It can also be a bunch of words thrown together, but the longer, the easier, or the harder it is to crack the password in general. They can be harder to remember if complex, but using a password manager can help you with that. Who uses a password manager in this room? That's a lot of hands. I'm very happy about that. There's still a few who don't. Please try to use one if you don't feel like and you have a good way to remember your passwords, go ahead. But if you want to remember all these complex passwords, a password manager can really help. But because they're so complex and often quite long, they can also be very hard to guess by others, by hackers, by people trying to enter your system. So that's something that's very positive about long, complex passwords. The second type of password is a PIN code. I think we all know this from our banking cards or cell phones, SIM cards, and some other things. Sometimes a PIN code to enter a door looks 1, 2, 3. Usually it's something else. And the bad thing about these is they're not so hard to guess because it's usually 4 or 5 digits, and you don't have that many possibilities. But they're often combined with a maximum number of guesses, like with your banking card, it's 3, your SIM card as well. So if you go over that number of guesses, it's blocked for a certain amount of time, at least. But they're fairly easy to remember. That's why we like to use them in certain cases. And usually, they're only access, or you can only use them with a physical thing, your banking card, your SIM card, the lock on your door. So without those physical things, those PIN codes would be useless because on the web, we usually don't use a PIN code. A pattern. Who uses this on their Android phone? It gets used quite a lot. Just because it's an easy way to enter a password instead of typing letters or numbers, you just swipe on your screen and do a pattern, which in the back end usually just translates to a bunch of numbers anyway to a password. But that's not your concern as a user. You just want to swipe and do the pattern you can remember. And one of the downsides of this is that touchscreens often reveal the patterns because you have greasy fingers and you leave the pattern behind. So if you wipe your screens long enough, enough at least, that's fine. And a lot of people use their initial letter or lucky number for the pattern. I'm not going to ask who does this, but you know who you are. The positive thing is, again, it's very easy to remember. Like a PIN code, a pattern is something that you can enter very quickly, that you can remember quite easily, and you can enter. It's a nice user experience. So what's the problem with passwords? If you have a field and you want to log in, I already have my password filled in. Of course, I forgot my first password. You can never log in from the first try, right? So I'll type another one, and then try again. Third time's the charm, right? Try again. Doesn't work. So I have to reset my password. Nothing to do. We all have this happen before. So I type password. And then you get this message. We've seen this message before. So we all think we know our password, and we're quite certain that we typed our password correct, and still when we reset our password, it tells us that the new password is the old password. And this is really annoying as a user, and this is one of the reasons why I hate passwords. I hate passwords. I'm going to say this quite a few times during this talk, together with use a password manager. Those are the two key things I'm going to be saying a lot during this talk. So passwords can be really annoying. At least remembering and entering them can be really annoying. A password manager can help you remember them and can help you enter them. So it makes it a bit easier, but you have to use them all the time on all of your devices, or it gets a bit annoying as well. And user data can get stolen. If you look at the last year alone, Google lost 52.5 million records of data. This was private data, no passwords, but still, this year, it came to light that they stored a few of the business passwords, business account passwords, as plain text. So if one of those gets stolen, that's not a good idea. Facebook, through Cambridge Analytica, 87 million. Again, no passwords, just private data, but still. Quora, 100 million encrypted passwords. Luckily, MyFitnessPal, 150 million encrypted passwords. You can see that the number is going up. Marriott Hotels, 500 million user records been stolen last year. Luckily, again, no passwords, but as we've seen, even big companies like Instagram and Google sometimes still store passwords as plain text instead of hashed and whatever. So should somebody be able to steal those, that's a very bad thing. So passwords usually are the weakest link in our authentication system. At Auth0, we have this nice option, which I don't know if you can read, but it's kind of breach password protection. If you try to log in with credentials that have been breached before, that are known to have been stolen, we will send you a message and you will have to change your password anyway. Google also has a plugin that does more or less the same. It's a Chrome plugin. So it's useful to use one of those. So you know that if your passwords have been breached, if they have been leaked somewhere, you can change them in time without you, with you knowing that they have been breached, and you can change them wherever you use them. So tips for a good password: use a complex password, don't use personal data, don't reuse passwords. I'm not going to ask who uses passwords, but a lot of people do. And change your passwords frequently, and that's something that's annoying. To be very secure, you should save them once in a while, or change them once in a while, but most of us don't do this. Fast forward a bit again, we end up at passwordless, which is a bit shiny and new, and we don't need passwords all the time. And the most common example of this is a one-time password. A one-time password is valid for one-time use only, often expires after a certain amount of time. So often it's only valid for 30 seconds or a few minutes, and after that you will not be able to use it anymore. And it's usually, or it's always, sent directly to the user. It can be sent in an SMS. And if you're using iOS or Android and you get an SMS with a one-time password, your keyboard will allow you to just tap on the number you just received, and you can enter them in the websites very easily. Like so, I just got my one-time password, and it ends up on top of my keyboard. The same goes in Android. But not all telecom operators are as secure as they should be, so the SMS messages can be intercepted. It's a low risk, but it's still a risk. And you need your cell phone on hand, of course. So you need, if you're working on your laptop, you need a second device, your cell phone, close to you to use that one-time password. So that can be annoying. And they can be sent in an email or through a magic link. Like if you use Slack and you don't want to type in your password, you can request a magic link. The good thing about that is you don't need a second device. The bad thing is emails can be intercepted as well. Everything can be intercepted, I guess. And the third way is an Authenticator app. Is there somebody who uses Google Authenticator? A lot of people. Nice. And what this will do, this will generate a one-time password on a timed basis. So every, I think, 30 seconds, it will generate new ones. We have our own at Auth0. It's called Guardian. It does the same thing. It generates a code that you can use to log in. And there's a bunch of others do, Lastpass, Authy, even Microsoft has one. So at least if they think that it's a good idea, then it must definitely be a good idea. So there's a bunch of choices to choose from, and they all more or less do the same thing. They create a one-time password that's often just valid for a certain time. And sometimes they can also push them to you. So you just click on a push message on your phone, and you're already using that one-time password. So time-based, they expire. Push-based, you can click on a push message instead of copying the number and pasting them on the website that you're using. But there needs to be a shared secret between you, the service, and the app that's generating those tokens. So if those get stolen or leaked, you end up with a problem. But let's all assume that these apps know what they're doing, and these secrets are safe. And then there's social login. I use a social login once in a while to log in. I'm a big fan of it because it's very convenient. It's one less password to remember. I just have to remember the one password to my social provider, Google for instance, and it will take care of all the other things for me. I only give the password to a service I trust. I trust Google, even though I just said that they lost a lot of records earlier, and they don't always store them. They sometimes store them as plain text, but I still trust them because I think they know what they're doing. But you rely on another service, so if that service goes down, your users cannot really log into your service, so that's not always the best of ideas. Some other authenticator APIs. It's me. It's something typically from Belgium. Yodi, it uses facial recognition to log you in. Voice it, your voice and facial recognition to help you log in instead of that password. And all of these are often used as a second factor, right? Nobody logs in with just this one-time password most of the time. Usually it's a second factor to make your password a bit more secure. Lastly, the Web Authentication API. It's a new API. It's often called WebAuthn. So if you want to Google about this, this is the way to go, WebAuthn instead of the Web Authentication API. And what it is, it's basically key-based authentication. So you have a private key and a public key, and by using these together, you can authenticate. And they require a hardware authenticator, which looks a bit like this. It looks like a USB drive. I have one on my keys. It's very small, so you will not be seeing it, be able to see it in the back. But let me just plug that in for later. So it looks like a USB drive, but what it is, it's not a USB drive. It has a private key on it, and it's able to sign certain things with that key, or issue public keys for that private key as well. And they're often connect to USB or Bluetooth or NFC. If you're on a phone and you don't have it, you can always use those as well. They're useful. So who has one of those? That's not too many hands, right? So it's a good idea that we can do key-based authentication, but if nobody has an authenticator device, that sucks. So let's see it in action first. I have this big login button. If I click on it, my Chrome is going to ask me to touch this USB drive I just inserted. I'm on localhost, so I have to click allow. But once I do this, I basically get back a public key raw ID, which I can use to authenticate later on. So I basically identified myself through this authenticator device as this is Sam. I'm going to save this raw ID and this public key somewhere on the server, but this is me. But I asked before who has one of those, and I saw 2 or 3 hands, so that's not convenient. But I'm happy to say that most modern devices have a built-in authenticator device. So who has a cell phone or a laptop or desktop that is less old than, let's say, 5 years? All of us, I guess. And most modern chipsets have a special chip including in them. Apple has the A2 chip, Intel has its own one. All of the chip manufacturers or motherboard manufacturers have this special chip including in their chipset that does nothing but have a private key and is able to sign stuff with that private key and issue public keys for that as well. So knowing that, we don't really have to use this USB drive I just inserted. We could also use my laptop. And because I'm on a fairly new MacBook Pro which has Touch ID, I can just use that instead of my USB drive. So if I touch my Touch ID, I just authenticate it with my fingerprint and my built-in authenticator device. So no need to have this external one. Most devices have it built in. And if you don't have Touch ID, you might be able to unlock it with a password, sadly. But you might be able to unlock those built-in ones in another way. Cool. So how does this work? Because it seems a bit abstract. You connect something to your computer and you get back some random ID or some random public key. We first need to register credentials. So this API is 2 methods, one to register credentials and one to use these registered credentials to authenticate further on. So our user is going to send his username to your authorization server, not a password, just a username to identify himself. And the authorization server is going to back a challenge. This is going to be an unsigned integer array with some random data, so basically just a bit of random data. We send it back to the browser, and the browser is going to send this to our authenticator device. This happens by the browser because it's a browser API, and we don't have access to the authenticator device directly, but through these 2 methods we can send stuff to that. So the authenticator device is going to ask me to touch it or to touch my Touch ID, some user verification, and once that's okay, it's going to sign this challenge and send this signed challenge together with a public key back to our browser, which is going to relay this to our authorization server, and we can save this public key for later use. So the next time our user wants to authenticate with this authenticator device, we just enter the username again, and our authorization server now has this username together with a public key information saved somewhere. So it sends back a new random challenge together with the public key raw ID, so we know which key to use on this authenticator device to sign the challenge. And it's going to sign it again, and if all goes well, we do the user interaction again. We send the sign challenge together with the public key again. And based on this sign challenge and the public key we saved on our authorization server, we can verify that it has been the same person that registered the credentials in the first place. And we send them to the authorization server. So let's look at some code, because we're at a web conference and I think a lot of us like to code. There's, like I said, two methods, one to create new credentials and one to use those credentials. The first one is navigator.credentials.create, which accepts a config and will return an attestation object together with some public key information. And the config is a random challenge, some random data to sign to verify later. Some information about the relying party, your authorization server, the server handling the authorization for you. Some information about the user ID or the username and stuff like this. And then some information about the authenticator that you're using. If you want to use a built-in one, which is platform, or an external one, non-platform, or you can just choose to accept all of them, that's also fine. And if you want to have user verification, because not all authenticator devices have verification, this USB drive I have to touch, but it's not going to verify if I touch it, or you touch it, or you touch it. Well, if I use my built-in one with Touch ID, it verifies that I use that one with my fingerprint, right? So it verifies the user. So that's a difference, and you can choose to only allow those, for instance, if you really want to. So it's really granular, and you can really tweak those permissions to your liking. And then some information about the attestation as well. The second time that once you've created your credentials, once they're saved on your authorization server and the keys are created on your authorization or authentication device, you can use navigator.credentials.get, which is this line, and it accepts a config as well, and this will basically also return an attestation object. Again, public key information, a new random challenge, and then the raw ID of the credentials we got back when we registered our credentials in the first place. So when you register, you get back a public key with a raw ID. You save those, and every time you want to use this one, you use that raw ID, send it back to the authenticator device, and it knows how to sign the challenges from that point onwards. And then again, some information about the authenticator device, like do you want user verification or not. There's still some issues to be solved, because this is a very new standard. Like I said, it became a W3C standard in March. One of them is user credential management. For the moment, you can store new keys on them. You can store new user credentials, but you cannot manage those. You cannot delete them. You cannot change them. All of this has to be implemented by browsers, or can be implemented by browsers, because the spec says may, which is very vague. It just means like, do whatever you want to do. You're okay to do it, or you cannot, whatever you want. But no browser really does this. I think Edge had some form of implementation, but they're moving to Chromium now, so they're going to fall back to the Chrome implementation, which doesn't have this. And a second thing is cross-device credentials. If I register my credentials on one authenticator device, they're not going to be on all my other authenticator devices. So if I register one on my phone, I will not be able to log in on my laptop until I register those credentials as well, because it's a different private key that's going to sign your challenge, right? So this is still something that needs to be worked out. The same thing is if your authenticator device, your phone, your USB drive, your laptop gets stolen, there needs to be a way to easily revoke all of the credentials issued by that device, which at the moment does not really exist yet. But it's a W3C recommendation, which means it's a standard, and all browsers have started or have implemented it in a certain way. It's been in Chrome for a while, Firefox, Edge, and Safari Tech Preview behind the flag, because we all know that Safari is a new IE, right? But if you want to use it on Safari on desktop, in the Tech Preview behind the flag, it's possible. If you want to use it on your iPhone, no luck, it's not possible. If you want to use it on Android and use Chrome on Android, you can perfectly use it together with your Touch ID as well, or Touch whatever it's called on Android. So it works on Android, does not work on iOS for the moment, and Safari is a bit slow to implement this. So where can I use this already? Google allows you to use this as a second factor. GitHub allows you to use this as a second factor. A lot of websites have started to implement this as second factor authentication instead of this one-time password or instead of some recovery codes. just to make the authentication process a bit more secure. And in the future, we hope that this will become the first factor, not the second, but there's still a few problems that needs to be solved before that's really going to be possible. We created this website, which is webauthn.me, which has a bunch of information about it. It has an interactive, if I can find my mouse, tutorial, which you can follow. And then some information, general information, and a debugger, because these two methods, they accept this config objects, which are, they have a lot of options, and these allow you to change them and test them real live in a browser, so you can play around with the config and see what happens, and then tweak the config to your liking. So if you want to know more about it, it's webauthn.me. So let's summarize. Boo, passwords. I don't like passwords. One-time passwords are cool, but it's just a step in an intermediate step in between using passwords and using passwordless in a certain way. But WebAuthn is even cooler because it allows you to use private and public keys to authenticate, which are much more secure, and you don't need to remember your credentials yourself. WebAuthn.me, our blog, has some nice, interesting articles about it, and the spec is also available if you really want to read the spec, which is kind of readable for a W3C spec, which isn't always the case. This one is doable. These slides will be at this address. Right now, they're the old ones because I have to fix some tests before I can upload the new ones, because it's just a React app. Maybe later tonight, maybe tomorrow. Thank you. Are there any questions? In the back, I saw a hand. Let's keep the staff guy running.
So some services still insist on asking you for security questions and answer. I'm sorry I missed the beginning of the talk, but did you talk about that, and what do you recommend?
I did not talk about that because security questions often are very easy to guess. You just have to go to somebody's social profile to get their city that they were born in, or the name of their pet, or their mother's first name. So there's better ways of recovering lost passwords, like a phone or whatever.
But if you have to use those services, if you don't have a choice, what do you recommend then?
Then try to make your questions not, the answers to those questions not as easily findable, so don't take something personal like mother's first name or pet's name, but use a question that the person still is going to remember, but it's not something they can figure out on social profiles.
So one thing I heard and I started using is just pick any random security question and just generate another password for it and save it in your password manager.
Indeed, a lot of people they don't remember, first of all, their answer, and a lot of people have started to use the forgot my password functionality just to create a one-time password again and again and again, so they don't remember their passwords, and they just request a new password every time they want to log in. And since you just get an email to change your password, it's maybe 20 seconds longer than the regular process, so that happens, yeah. Nothing to say about that.
I had another comment, but I don't want to have a monopoly of the questions.
Are there any other questions? See in a hand.
Hi, thank you. In Authio, did you plan to implement WebAuthn?
Yes.
When?
Yes.
Thanks.
It's on our roadmap. We have some internal working demos, but I cannot promise you any time frame other than yes. Any other questions? There's another hand over there.
Hi, thank you for your talk. In your slides, you showed that first you had to always ask for a username. Is that always the case with WebAuthn?
Not really, but if you're going to save those public key credentials somewhere in an authorization server, you need a way to identify the ones you want to be using. So that's the username or email address that you're going to be using this. So the user is going to say, hey, my name is Sam, I want to log in with WebAuthn. Then your authorization is going to check, oh, do you have a user for username Sam? If so, I need to send the raw ID of this public key credential that he registered in the past to the authenticator device, so we can sign stuff with that key and do the whole process again. So you kind of needed to get the right public key credentials to authenticate, but the standard itself does not really require you to. If you figure out another way, go ahead, but it's the easiest way.
Thank you.
You're welcome. Some more questions? The person in the back still has a question?
So just a follow-up question on what the gentleman over there asked. Doesn't that mean you have a user enumeration problem? Can I not go to your service and ask, is this person in the system? You know, if I enter an email address.
In theory, you could do that, but since if you want to say, I'm Sam and I want to log in on this service with WebAuthn, I'm going to send you a raw ID of a public key, which you will not have the private key to anyway, so you will not be able to use this. If I go to any website right now and I type in a random username that I know exists and type a random password, I also cannot access the service with that username. So getting a username is not the hardest, it's not the most critical thing. It's those passwords or those public-private key pairs that are the thing that protects you. The username is only to identify yourself.
So, all right, but you could still, like once you know a user is in the system, you could launch some kind of spear phishing attack and target that user in particular and try to get the private key from them.
You will never, these private keys are on those chipsets or on those devices, so they are, you cannot get them off those devices. These chipsets and devices are built, hopefully, in a way that they can only sign stuff, but you cannot take anything off of it.
Okay, fair enough. Thanks.
Okay. All right.
Thank you.
Thank you.